Now let me show you something else interesting you can do with light and sound. So here we go. Let's select the light meter and the microphone both at the same time. So they're both being sampled now at 2400 hertz. And I'm going to start recording. And let me just get this thing spinning. Okay. So now what you're seeing here, these little blips in the light meter, are because there's a window over there. So these little blips in the light meter actually are going to allow us to keep track of how this thing is rotating. That's just a cheap little trick that I figured out. Okay, now let me play a 1 kilohertz sine wave to this thing as it's rotating. Okay, so sorry, it took me a while to figure out that the speakers on my iPhone were facing away, so I turned them around, and so here now we have large excursions of sound. So let's have a look at this data. Let's zoom in a little bit. This is where I figured out how to do it right. So here we see where it's rotating, and then it's sort of facing the window, and then it's turning around, it goes faster and faster, and then it's facing the window and it's turning around. So basically each time the light meter goes up, it means it's making a rotation. So let's look at the Fourier transform as we're doing this. Okay, so here we go. And we're going to have to move this up to 1 kilohertz as we're doing this. So now look at what's happening. As the thing rotates, look what the Fourier transform is doing down below. It's moving from one lower bin to the higher bin, to the lower bin to the higher bin. So you're seeing a Doppler shift here. As the microphone approaches the source of the sound, you get a higher frequency. As it passes by and recedes, you get a lower frequency. Then you get higher, then you get lower, then you get higher, then you get lower. Pretty cool, Doppler shift.